I think it's because people don't remember this basic idea what the plan is. So the main idea is that we don't want fractions, and so we're going to get rid of them. And we do that the same way we've always done it with fractions, right? So this is an equation that we totally could solve without getting rid of fractions, right? We subtract the 1/4 x over to the left side, or I guess we would subtract the 1/2 x over to the right, and solve normally. I mean, it really would not be a problem. However, I do want to illustrate the basic idea here. So we want to multiply by the least common denominator to get rid of the fractions. That's the plan. And then that'll leave us some equation that doesn't have fractions in it, and we just solve it. However, sometimes it'll be quadratic, and we'll have to use a quadratic formula or factor it. Sometimes it'll be linear and therefore easy. Sometimes it'll be some other kind of equation. I guess in this class, that's really all you've got is those two options. So that's what I want to do. So what I'm going to do is I'm going to find the LCD of everything in the equation and then multiply both sides by it. So in this case, my LCD, so those x's are in the numerators. So my LCD is just 12, right? So the smallest number, the 2, 3, and 4 all go into is 12. So I'm going to multiply both sides by 12. When I say both sides, I'm really going to do this. Actually, I don't want to do it right there. I want to do it one step lower. I'm going to do 12 times 1/2 x plus 12 times a third equals 12 times 1/4 x. And I really want to impress on you that writing the LCD next to each term is really helpful. It makes it so much easier to avoid screwing up, basically. Most of the mistakes on questions like this are because people are trying to go too fast and they're trying to remember too much and don't want to write things down. And that's just not a good way to do this. You really want to just go slow, write out everything, and everything will be easy. That really is the secret to doing this. So we're just going to cancel. 12 and 2 cancel, leave me a 6. 12 and 3 cancel, leave me a 4. 12 and 4 cancel, leave me a 3. And so the thing I end up with here is 6x plus 4 equals 3x, right? Could not be easier. This is definitely not an equation that is going to challenge you. Subtract 6x and we get 4 equals negative 3x. And so x is minus 4/3. That's it. That's how you do these. Obviously, this gets harder when you have variables in the denominator, so let's see one of those, right? Okay, so now what my LCD is, I need something that 3 and 5 and x all go into, and after adding and subtracting rational expressions a couple of topics ago, I cannot imagine this is much of a challenge for you, but that is 15x. And so I'm going to write 15x by each one of those. 15x times 3 over 5 plus 15x times 1 over x plus 15 plus equals, that's actually what I meant, equals 15x times 2 over 3. And because we have actually found the least common denominator correctly, we're going to end up canceling all the denominators. And that really is the key here. So 15 and 5 cancel, leave me 3x. X and x cancel, leaving me 15. And then 15 and 3 cancel, leaving me 5x. And so now I've got 9x plus 15 equals 10x. And again, not a thing that I would imagine is going to challenge you. Subtract 9x minus 9x, and we end up with 15 equals x, and we're done. So x is 15. Now, one of the things that you want to check is that the answer that you get here can potentially make one of these original denominators 0. And if that's the case, you have to throw that answer out. Now, sometimes that will mean that you throw out all the answers, which happens sometimes, and then there's no solution to your equation. Other times, it will mean you throw out some of the answers, and there are others left. So I believe I got one of those coming up. So let's see what this one looks like. All right, so my LCD is pretty obvious. It's w plus 1. LCD, w plus 1. So I'm going to multiply everything by w plus 1. We get w plus 1 times 3 minus w plus 1 times 6w over w plus 1 equals w plus 1 times 6 over w plus 1. Now the canceling here is easy. Cancel, cancel. So we get 3w plus 3 minus 6w equals 6. So just simplifying here, combining like terms, I get minus 3w plus 3 equals 6. So I subtract 3 from both sides, minus 3w equals 3, and w equals -1. All right, so that looks like a good answer, but it's not. You got to check to make sure that it's not among the things that are not in the domain of any of the original rational expressions. We would call -1 here an excluded value, because it would make one of the denominator, at least one of the denominators 0. It would make 2 of them, but just making one of them 0 is enough to exclude it. So w equals -1 is an excluded value of this equation. So the fact that that's our only answer means that we throw this out. Right? So this is not a solution. So there are no solutions. Because our only value was excluded. All right, let's see some more of these. Maybe ramp up the difficulty just slightly. Maybe not. this one's not so bad. So same strategy. My common denominator here, x squared. X squared, so that's what I'm going to multiply everything by. So we get x squared times 1 plus x squared times 3 over x equals x squared times 28 over x squared. So let's see what we end up with. We got x squared plus, this cancels here. So we get 3x equals 28. I'll subtract the 28 onto the other side. Because when we are solving quadratic equations, we always want to have equals 0 so that we can factor or use the quadratic formula, whichever one's appropriate. This one factors pretty easily, so I'm going to go ahead and factor it. If you didn't see that this factors, totally fine. Just use the quadratic formula, it'll work for you. So this is going to be x plus 7, x minus 4 equals 0. Now, before I finish solving, notice that the only excluded value is x equals 0, which is not going to be either of these. So we're not going to have any excluded values. I really just wanted to do one where there are two solutions, right? So here we have x plus 7 equals 0, or x minus 4 equals 0. So x equals -7, or x equals 4. And again, -7 not excluded, 4 is not excluded. So we actually have two solutions. X equals -7, x equals 4. There you go. Next example. All right, this one's a little bit messier. So again, we're going to start by factoring everything, right? P squared minus 9. I hope you guys have been doing enough of these that you know that that's a difference of squares, which I've been trying to use a lot. And so my least common denominator, it's a terrible C, is P plus 3, P minus 3. Right, because my denominators are P plus 3, P minus 3 right here, just P plus 3 here, and just 1 here. So every one of those, every one of these terms is going to get a copy of P plus 3, P minus 3. So we're going to have, and this is where I have trouble convincing people to write things out. But you totally should write things out. Taking a little extra time to write things out. Oh, I've given myself a little bit too little room here. We're going to go ahead and move that down. Down to here. There we go. Taking a little extra time to write things out makes things so much easier. Or it's not even that it makes it easier, because you could totally do this without writing it out, but it makes it so much harder to make errors. And you can see I've run out of room here. We're going to get a little tight here at the end. but that's okay. So the reason this makes it so hard to make errors is that you can literally see all the things that cancel right next to each other. And it's only the one step that you have to write out, or that there's a lot of writing to do. It's p plus 3p minus 3, yeah. Right, and then it immediately shortens up. So I'm going to go ahead and multiply all this out, and then we're going to combine like terms. All right, let's clean it up one more step. 36 equals 2p squared minus 6p minus p squared plus 9. Don't forget to distribute your negative. So I'm going to get those cancel, leaving me p squared, so I have 36. Hang on, let's try that again. 36 equals p squared. P terms, we just got minus 6p plus 9, minus 6p plus 9. Did I do that right? Yeah, I think so. Then we're going to get everything over onto one side. So I'm going to have 0 equals p squared minus 6p minus 27. And we're going to go on to the next page and finish that up. I'm going to flip this around so it's p squared minus 6p minus 27 equals 0. And that factors. And again, if you don't see that it factors, feel free to use the quadratic formula. Not hurting anything by doing that. So this is going to be p minus 9 times p plus 3 equals 0. So p equals 9, or p equals negative 3. Now, before I stick a box around that, let's go see what the excluded values were, because I don't remember. All right, so p squared minus 9 was this guy. And so if I try to plug in, was it negative 3 or positive 3? Negative 3. If I try and plug in negative 3 in here, I'm going to get 0. If I put in negative 3, I'll get 9 minus 9. If I put negative 3 in here, this will also give me 0. So negative 3 is excluded. Positive 3 is also an excluded value, but we didn't get positive 3, so we don't have to worry about that one. So negative 3 is excluded from this and also from this. And so we're going to toss out negative 3. So it can't be that one. So it has, so p equals 9 is the only solution. So just because you throw out a solution doesn't mean there's no solutions. There could be potentially others, like there was in this case. All right, let's see one more thing, which is I want to show you how to solve formulas for variables. Now, it turns out that this is actually a really important skill in sciences. The farther you go in science, both physics and chemistry, and probably others as well, I would imagine, the more important it is to be able to isolate the variable that you're looking for. So here, this is, I don't know what these are. M's and V's make me think physics, mass, and velocity. But I don't know what this is the formula for. But I've got capital V equals little m times little v over little m plus capital M. So one of the things to point out is that case sensitivity is important here. Little v and big V are different different variables, and little m and big M are different variables. Yeah, so we're solving for little m. And so this is a rational equation. This has a fraction with polynomials in it. And so we're going to use the same techniques as always. We're going to get rid of the fractions by finding the common denominator and multiplying by it. Now, the common denominator in this case is really easy. It's little m plus big M. LCD m plus m. And so I'm going to multiply all the terms by that. So we'll have m plus capital M times capital V equals mv over m plus capital M times m plus capital M. Unsurprisingly, the denominators cancel. And here I've got little m times capital V plus capital M capital V equals little m little v. Now, here's where we get to a trick that you may or may not have seen before, which is I'm trying to solve for m, or for little m, but I have two of them, so which one do I solve for? And the answer is it has to be both, but you can't do it while there's two of them. So what I need to do is get them all on one side and factor it out, factor that little m out. So what I'm going to do is all the terms that have little m in them, I'm going to get them all on the same side. And all the other terms that don't have a little m are going to go on the other side of the equation. So if there were like 10 terms and 4 of them had a little m, I would get all those on one side and the other 6 would go on the other side. So it really is everything with a little m on one side, everything without a little m on the other side. So I'm going to subtract little mv over to the left side. So we're going to get little m capital V plus capital M capital V. Oh, that's not what I meant to do. Minus mv equals 0. And then I'm going to take, then I'm going to get this term with no little m's in it over to the other side. So by subtracting again, so little m capital V minus little m little v equals minus capital M capital V. And that might not look better yet, but now the left side has a factor of little m in everything, and I can pull that out using the GCF, right? So little m times capital V minus little v equals minus capital M capital V. And now what I can do, let's rewrite that up here. So we've got little m times big V minus little v equals minus big M big V. What I can do is divide by this term. Divide by all the stuff that's not little m. Cancels over here and leaves me with what I wanted. Now, mathematicians and physicists and other mathy types tend to like to get rid of the negatives if they can. And so I want to do that here. By using a trick I showed you earlier, well, not earlier, not in this video, but using a trick I showed you, I believe when we were adding and subtracting, I don't remember which topic it was in. But basically, I'm going to factor a negative out of the denominator there by doing this, by switching the order of subtraction. And then I have a negative over negative, which cancels. So I end up with little m equals capital M, capital V, they're getting smaller now that I'm running out of room, over little v minus capital V. And that's my answer. And that's all I really wanted to say about solving rational equations. So let me just hit the first screen again and say that the main plan is to multiply by the least common denominator to cancel all the fractions and then solve the result. Solve the resulting equation. Sometimes that means factoring, sometimes it means using the quadratic formula, sometimes it means just solving a simple linear equation, right? All of those are things that you might end up having to do, right? So sometimes you get a simple linear equation like this. Sometimes, so we had a simple linear equation here, but it didn't work because the value was excluded. So you always got to check to see if your solutions are excluded values, and if they are, you got to throw them out, right? So here we get two solutions, but none of them are excluded, so we just get to keep both of them. Here we get two solutions, but one of them is excluded, and so we can't use it, and so we have to only keep the other one. And then sometimes we're just solving for variables where we're not trying to find a number, we're just basically rearranging things to be more convenient. So this is usually how formulas are made, by the way, is you'll start with some other formula and solve for the variable you're looking for, and lo and behold, you get a new formula. So that happens a lot. That's a really common physics thing to do, for instance. So yeah, there you go. That's all I really wanted to say about these things. Just remember, cancel your least common, or cancel with your least common denominator, and then solve what you get. All right, I'm going to go ahead and stop there.